finish up this chapter. So like I said, restoration, that is like where we take something like an old car, if you think about it, and you restore it, and you're going to put the original kind of leather, the original steering wheel, and the original kind of wheels, or whatever. You're going to try to put it back the way it was. And so two of the biggest projects is prairie restoration, because we've taken all the grasslands and we turned them into farms. So the Midwest part of the United States, where we're growing our corn and our soy, those used to be grasslands. And so we're trying to put that back. And then the largest project in the world is the Everglades project in Florida. So that's kind of where we ended yesterday. So here's some people doing some prairie restoration, and this is fun. It's like a game where it went. There it goes. So yeah, a biome. It's gonna give you the main ideas about each biome, like what's on my test, what's on the AP exam. You don't have to have everything memorized, but there's a few things that you need to know. First of all, here's the equator. It runs right up. If you look at the fat part of Brazil, it runs right above it. That's how to keep it straight. So, see, there's the fat part of Brazil. It runs right above it. So that's 0 degrees. At about 30 degrees north and south, about here, and about here, that's where you have all your major deserts. Do you see how when I went there and there, that's where all that yellow is? At the equator, that's where you have most of your rainforest. So that white green, right there, right there, right there, that's all rainforest. And we'll get into that, why that is when we talk about the atmosphere. The largest biome as far as like land surface is this boreal forest, or and the tundra. So those frozen ones. I'm sorry, what? No questions. Okay, so the boreal forest and the taiga, or the taiga, however you like to say it. So that's kind of where we are with the biomes. A climatograph is a little graph that helps you to see the temperature and precipitation. And I'm going to show you those on each page. So if we look at this little chart here, if you think about it, do you see like big trees in the desert? No. So you can't have trees if you don't have enough water. I'm kind of kidding, but I'm so serious. So the more precipitation you have, the more trees you'll have. So the most trees will be in the tropical rainforest. You have something called a tropical dry forest. It also has a lot of rain, but it has a dry season. So it's similar to a tropical rainforest, but it has a dry season. And then as you go to the drier climates, you're going to have things like your tundra is actually really dry, and your desert's dry. So that's what this graph is showing you. So anyway, things like coastlines play a role. That's fine. Aquatic systems, cool. So temperate deciduous forest. I'm going to show you the picture, and then I'm going to show you this stuff. So here's anytime you see the word temperate, that means it has seasons. We live in a temperate biome because we have seasons. Temperate. Temperate equals seasons. And so when you're looking at a climatogram or climatograph, either one, this bottom one, when it makes like a little curve like that, that means it has seasons. Now, if you think about the southern hemisphere, they have opposite seasons of us. So sometimes when you look at climatograms, since they start in January and they end in December, sometimes they'll look like this. And that just means you're in the southern hemisphere, but you're having seasons. You see that? So that bottom line is that temperature line. And then you can see it here, it's pretty good as far as precipitation goes. So that's us. We live in the temperate deciduous forest. Going back to the word part of it, the trees lose their leaves. When they lose their leaves, it makes for really nice fertile soil because you have all that detritus that's going to build up in the soil and make for a very nice nutrient-rich soil. So the trees lose their leaves. You have seasons, good soil. Hardwood trees, nothing really big there. Moving on to the next one. This is your temperate grassland. Going straight to the picture. The temperate grassland, look, you can see that you have seasons. See the red? So I can tell I have seasons. And it's pretty dry. If I'm looking at, if I'm looking at the precipitation, it's around 40 millimeters a month. That's not very much. Ours was around maybe like 80 to 100. So that's a much lower. So there's that. So as far as the words go, the temperate the temperate grasslands, they are also called like prairies. Sometimes savannas are very similar. But anyway, you have pretty high extremes between the winter and the summer. And if you think about that, with the Midwest, their winters are super cold. And they can get to 100 degrees or more in the summertime. So they have, it's negative, or can get down to 0 or even negative temperatures. In the wintertime, they have a lot of snow. But then in the summertime, it's very hot. And that's because they're not near the ocean. The ocean helps to moderate your temperature. Anyway, they have less precipitation, and so they can be called a steppe or steppe or a prairie. Most of the time here, it's prairie. And this is the biggest thing. They have almost all been converted to agriculture. Because if you want to grow crops, it's nice. You don't have to clear out any trees. But this has the best soil. This biome has the very best soil. Everybody screws this up. So listen to me. When you're in the tropical rainforest, it rains every day. And when it rains, it's going to leach and wash away all the nutrients. Also, every bit of every mineral, nutrient, anything gets immediately taken up into biomass. Because think about how much biomass you have in the rainforest. This has the best soil. This grassland has the best soil because the grasses die and they wither and they replenish the soil, but it doesn't rain enough to wash all the nutrients away. This has the best soil. Okay, so that's very important. That's probably the most important thing I'm going to say today. So there you go, like I said, nice and dry. The temperate rainforest, kind of moving on to this one. If you've ever seen the movie with the werewolves and stuff, and it's a love story. Yeah, there you go. You ever seen Twilight? You're up in the temperate rainforest. So, there's a werewolf behind this tree. Edward's hanging out and he's going to jump off the tree and everything. No. If you look at the temperature, it is temperate. You can see the seasons there. And then it rains a lot. This is 300 millimeters. So this is around 60 degrees north and south of the equator. And so that helps it rain a lot. It's going to have coniferous trees. And I don't know if you know this, but coniferous trees were like the first kinds of trees. They evolved before deciduous trees. And they were hanging out around that time of the dinosaurs. And coniferous trees, like pine trees, they're needles. Have you ever seen like a cow or like a squirrel or something just go up and eat some pine needles like for a snack? Is that a thing? But like caterpillars, they'll eat the leaves off an oak tree like that, right? Nothing eats the pine needles. Pine needles are acidic because they evolved that as a co-evolution defense mechanism to the dinosaurs. I like dinosaurs. So pine needles are acidic. The reason I'm telling you that, I like dinosaurs, but I'm also telling you that because it makes for acidic soil. Because it has coniferous trees with acidic needles, you end up getting acidic soil. It has a decent soil. It's not the best, but it is going to be acidic. Anywhere you have coniferous trees, you're going to have acidic soil. Because the needles are acidic. Dinosaurs. Most of the original forest here, it's been logged. So as far as human impact, we logged it. If you ever watch like the logging shows on the Discovery Channel, all up in Washington, Oregon, the like Axemen or whatever, like they're in this temperate rainforest. So when you think of like the redwood forest, the giant trees, that's where we are. Okay.
Your favorite dinosaur? Do you have a favorite dinosaur?
How could I pick? It's like picking your favorite child. No, I'm just kidding. I'll tell you later. All right, tropical rainforest. It's on the equator. Do you see seasons? No. And then it's very rainy. So this is 300 to 500 millimeters a month of rain. So tropical rainforest, it has awful soil. Look, see? It's rain all year, very warm all year. Flat lines straight across on that climatogram. There's a lot of diversity. The reason you have a lot of diversity, diversity is going to peak. Diversity peaks near the equator. Here's the thing. When you have a lot of sunshine, you're going to have a lot of primary production. Primary production means photosynthesis. So you're going to have a lot of food sources, and you're going to have a lot of niches to fill those roles in the ecosystem. So diversity peaks near the equator. We'll have more slides on that, but I thought I would tell you. A lot of different kinds of organisms here. Next we have the tropical dry forest. If we look at this, here is your temperature. Do you see how I can tell it's tropical? Hot all year long, no change. And then when it rains, it like really rains. I mean, you have the precipitation of a tropical rainforest. It's just half of the year though. So have you heard of monsoons? Everybody's like you think of monsoon, you're like, oh, is that a storm? That monsoon is a seasonal reverse of winds. And so in these tropical areas, like the winds will blow one way half the year and they'll blow the other way half the year, and that brings in like this wet and dry season. We don't live near enough close to the equator to have monsoons, but if you live in a tropical place, it's like India has monsoons, for example. And if the monsoon fails, have you heard that word before? The monsoon fails, then you have a drought and everybody dies. So if the monsoon fails, you don't get the rain. Like that's, I'm always connecting stuff to social studies class. But anyway, Australia is this climatogram, but you have a lot of precipitation, but it's only for half the year. So tropical dry forest. Like I said, India, Africa, South America, North Australia, wet and dry season. So if it's not a rainforest and it's in the tropics, you're going to have these wet and dry seasons if it's not a tropical rainforest. Most has been converted to agriculture. There's that one. The savanna. A savanna is like a tropical grassland. Let me show you what I'm talking about. If we look at the climatogram, I can tell it's tropical because it's hot all year. See that? That's how you can tell, and it's hot. The room temperature is about 25 degrees, and so when you average in nighttime temperatures, 20 degrees is pretty warm if you think about it. Anyway, so look, this is the biome. Have y'all ever watched like the Discovery Channel? And there's like that one watering hole, and then the crocodiles are hanging out. And the wildebeest are like real desperate because there's like that one watering hole, and then they're like, "Hey, you go get some water," and it's like, "No, you go get some. No, you go get some water." And then that one that's real thirsty gets down in there and gets ate. This is the savanna, and so you have this again, wet and dry season, and so this is where desperation happens, and the wildebeest get eaten by the crocodile. Okay, and this is like, oh, it's plentiful, and this will turn green and beautiful, and then the zebras are happy, and then the Lion King happens. No, I'm just kidding. But that's this biome. So the savanna, again, you have this tropical sort of rainy and dry season, and it's because of the monsoons. And Lion King, there's the water hole with the wildebeest. The end. All right, so next one is the desert. Desert only has one S. Fun fact for today. And so this blue line is the precipitation. So yeah, not much of that. And then you do have a slight seasonality because deserts are most commonly found in 30 degrees north and south of the equator. They're not right on the equator, so they're going to have a little bit of seasonality. I think we're 38 degrees north of the equator, something like that. So, we're north of there. But if you go to Mexico, for example, or southeast, what's so funny? Oh,
my friend started playing music. I don't know.
Yay!
Like
Was it
that
the?
U2 album.
Was it like Sauce and Mayo? No,
No.
that would have been cool.
That was.
I really need to get out more. Anyway, you can tell it has a little bit of seasonality, but that's the desert. They're at 30 degrees north and south, and minimal precipitation. Some have sand, some have a little bit of vegetation. Their soil is going to be saline. That means salty. Have you ever tasted your own tears?
Yes.
That's sad. I know you always said yes. I've tasted my own tears. No, that could be that would be like the best name of an essay ever. Yeah? Yeah. Do it. Okay. Anyway, and have you ever bought eye drops? What are they called? Saline eye drops. If you ever tasted those, which I think that would be creepy, don't do it. But if you ever tasted those, they're salty too. So they're saline because your tears are saline. Like saline means salty.
Why are the soils salty?
Oh, the reason the soil's salty is because all the water evaporates. And when you evaporate water that has salt in it or minerals in it, but the salt stays. And so just natural groundwater is going to have, like if you're irrigating, we'll talk about that next unit, but when you have water that runs over the surface, it's going to pick up salts and it's going to dissolve, but then the water's going to leave and it evaporates. So it's going to have salty soil, and then, you know, your animals and such are going to have those dry weather adaptations. So that's desert. Tundra. So here's the tundra. Tundra also has pretty low precipitation. If you look here, the precipitation, this is 0. So the precipitation is low, almost as low as the desert. Tundra is actually called like a frozen desert. Yes, sir.
Sorry, I actually have a question about the desert.
Sure.
But as far as plants bringing moisture to the soil, what living there is in the desert through osmosis, how do they do that if there's salt in the soil?
What?
Like, if there's salt in the soil, that seems like a...
Well, there's active transport, there's passive transport, right?
Yes,
So
there is, but like, do they always just go out and active transport?
I'm not sure. I'll ask Miss Robson. That's her jam. I can tell you about the kinds of rocks in the desert. But yeah, and there's always adaptations. So a lot of them will be succulents and they'll have that waxy coating, they'll hold that moisture. But as far as
also have that thick syrup consistency.
right. So anyway, a tundra. Thank you for asking. A tundra is like a frozen desert, and so but not a frozen dessert. Okay, so it's really dry. They'll have a little bit of rain, but this is only going up to 40. You got to look at the scale. This is only going to 40 millimeters, so it's very dry, and so it's going to be very cold. And so this top peak monthly temperature is, 0. That's the high up here in the summertime. So pretty cold there. So the tundra, like I said, is very dry, minimal precipitation. You have to be careful when you're looking at the climatograms for a desert versus a tundra. They look almost the same, but it's going to be cold as crap in the tundra. So if you look at the temperatures, like it's going to be -20, but a desert's going to be like at +20. So they'll look the same, but you have to look at the scales. So really cold, very dry, and they're covered in this permafrost, which is a special word for permanently frozen soil. The permafrost is melting due to climate change, yay, and then people's houses are falling in because you have this soil that's always frozen, and when it starts melting, it gets really squishy and starts falling in. So it's kind of a problem in Alaska and Canada, for example. And so this is where the polar bears live, caribou, migratory birds. Most of the vegetation, okay, you can't have trees if you don't have water. That's the thing, I already told you that. My baby said that. I already told you that. I'm like, this is my fault. But anyway, few trees because you don't have enough water to support it. And then also, when things are low to the ground, it's going to be warmer. They're low to the ground. And so that's a good adaptation for the things in the tundra. Feeling better about all these biomes? It's not so bad. It's not so bad. So there's the tundra. I already showed you that. Boreal forest, also called the taiga or taiga, but not a tiger. I'm just full of jokes today. Also cold, looks very similar, the climatogram looks similar to the tundra, except that it's going to be a little bit more moisture, and it's going to be a little bit warmer. And here you're going to have the coniferous trees. What do you guess is going to happen to the soil? Yay! So you remember that because of dinosaurs, don't you? So the boreal forest, very similar, like I said, to the tundra. A little bit more moisture. I think this is between the tundra and the taiga. I think the taiga is like the largest biome, but together they're definitely the largest. So anyway, you have evergreen trees, so that gives you that acidic soil. This is your moose and wolves and bears and stuff. You are going to have a short summer, so you can grow some food, sort of, but it's short. The chaparral, here's how to keep the chaparral straight. If you can grow grapes there, like if you buy wine or your friends or family buy wine or olives, like it comes from the chaparral. So let's list that out, okay? Ready? California, Italy, like maybe the south of France, Mediterranean, right? Parts of the Middle East on the coast, Eastern Australia, Chile, yeah, that's everywhere. Those are where you get the grapes and the wine and the olives. If that's where that's the chaparral. That's how to keep that straight. So anyway, it is also Los Angeles, and they have vineyards out in Los well, in California, that's the thing, Napa Valley, ringing some bells. Have you ever been outside before? Okay, good. So anyway, they have a rainy season. So there's your rainy season. So Southern California actually has monsoons. That's why they have like forest fire problems. When the winds reverse, sometimes they can be really strong, and it makes the forest fires worse. Anyway, pretty as far as the seasons go, it's kind of warm all year. And I don't think the PowerPoint says this is where you get wine from. But look, these are places to get wine. And olives, both. Anyway, small patches around the globe, frequent fires, and most of the vegetation actually is adapted for fires, and they need fires. But look, all of these places, this is where rich people live, right? So they don't let the stuff burn because they're like fancy house made out of stuccos there. So anyway, adapted for fire. So most of the vegetation actually requires fire to like reproduce, but we suppress those fires because people live there.
Is that why there's so like frequent forest fires in California?
Yes, and because it's supposed to be like that. So anyway, good question. This is a big deal. This I'm gonna come back to that rain shadow effect. Make sure I do because it's on the test. Yes.
Well, what's the I guess average yearly or per unit of time amount of fires typically needed for production?
It would depend on which place you're talking about. All right. So talking about this little picture here. This right hand side. This is elevation, and these are biomes. So there is this principle that says that if you're in Mexico and you start climbing a mountain in Mexico, or maybe like Arizona, somewhere that's kind of deserty, and you start climbing a mountain, you're going to go through the same biomes that you would encounter if you were to walk to the North Pole. So let me like explain it. So anyway, I'm at the bottom of a mountain, also ground level, and you know the equator is 0, and like the North Pole and South Pole 90 degrees. I'm leaving no child behind. I'm trying not to. So anyway, you start climbing the mountain, you might hit a desert. Well, if you start walking towards the North Pole, you might go through the Midwest, and there's your grassland. So grassland up the mountain, grassland up in latitude maybe at 35 degrees. All right. So now I'm at a woodland. So this would be my deciduous forest, maybe around 40 degrees north of the equator, or maybe around 7,000 feet. So climbing the mountain some more. Pine woodland. This would be kind of analogous to your maybe like your coniferous forest or your taiga. So I'm getting on up there about 10,000 feet, and then here I'm getting more to tundra. So at the top of the mountain, I'm at tundra. At the top of the world, well, there's an ocean. But at northern California, no, Canada, you would be at tundra. See, as you go up a mountain, it's like going toward the equator. So this picture is on your test. This is the picture that is on the test. So there you go, and I just explained it. All right, yes, ma'am.
Have you told the difference between coniferous forest and boreal forest?
The coniferous forest will have way more rain.
Okay.
It's going to be like up to 300 or 400 millimeters a month. That's the difference there. I'm going to draw. Y'all know, have I drawn for y'all? Y'all know I'm good at drawing, right?
Besides your giraffe, I don't think you've drawn much.
I'm sorry. Well, here you go. You ready? All right, so we're in Seattle. We're having some coffee. I want to go to Seattle. I'm trying to make that happen this summer. Trying to get a little teacher grant going. This is what I do in my free time. I write grants. Some people give me free money. And y'all know, like, Mount Rainier, Mount St. Helens. Y'all know those are mountains out there, right? Like,
Yes.
Okay. And then they're volcanoes, really. Okay, but there's some mountains. All right, cool. So I got some mountains. And then I got, like, Seattle. And then everybody's depressed because it rains all the time. So they just go inside and drink coffee. That's coffee. Looks good. Alright, and so here's the ocean. Hang on, I can make this better. Yeah. And so what ends up happening is you have this moist air coming off the ocean, and it rains quite a bit in Seattle and on the West Coast because this warm, moist air actually gets lifted up, and it's going to rain and drop all the moisture on this side of the mountain. And then over here, this is like the Badlands, right? Like in Idaho and stuff. Super dry. Like all of that area, Nevada, right? Like Las Vegas is in a desert. And so there's mountains, and then you have California, and then you have the ocean. So if we were to look at a map, like everything to this east side of the mountains is super dry because all the rain gets dumped on the mountains and to the west of it. So this is called the rain shadow effect, which that's not the best drawing, but I can do better if you need me to. I'll try to do better. Let's just draw one mountain. A mountain, that looks good. And so we got some clouds. It's raining. It's raining because like this mountain is going to lift up that air, and as it lifts it up, it's going to like cool and condense and make rain. That's from the 3rd grade. You've heard that before. But then on this side, there's no moisture. So this is actually called a rain shadow. This is the rain shadow effect. That's it. There's nothing else to it. Yay. Okay. I think I had words on the PowerPoint for this, but I kind of wanted to explain it too. No, there it is. So a phenomenon that occurs when air going over a mountain releases moisture on one side, creating an air region on the other side. I guess I could have just said that, but I wanted to explain it. Yes, sir?
So why is there like so many droughts, or why was there like a big drought in California recently?
Climate change. Plus, California is dry anyway, so people just live there. Several like mine. No, just kidding. But it's dry anyway, and we've dammed up the Colorado River like 20 times or something. It doesn't even reach the ocean anymore. We'll get it in water, but it's, I'm sorry, that sounds so depressing. Use your little boards. Let's answer these questions. So, mutualism is a form of species interaction where ... Go quickly. Both BC. Okay, looking good. Hold them up. Go team, go. Yay, see, you guys are so smart. All right, next. Which is not an example of an exploitative relationship or interaction. Not an example of exploitation. Y'all know what the answer is when ABCD like this, right? Yay! If it doesn't work, throw it in the trash can and go get another one. Here you go. No, I don't want to give you that. Go get a different one. An example of resource partitioning is, this is the nuthatch and the yellow-bellied sapsucker. Remember that guy? Oh, yeah. I need to take some pictures of that and put it out for the world to see. So I think everybody needs to see that. All right, A? Good, good, good. Next. Which statement about trophic levels is not true? Not true, not true. Oh, I found it. I got it. I got it. Yay! Hurry up, hurry. D is the right answer. Yay! Alright, primary succession would take place on all of the following except primary succession. That means you have to start at step 1. You don't have any soil. So, looking for, good, I'm seeing it. Show me your answer. I see some corrections going on. Good for you. B, yes, good. Next. Because communities can undergo, oh no, nope, next. All the following are ways to control invasive species except the class is split. Alright, I'm starting to see the answer I'm looking for. I'm seeing B and I'm seeing D. You can actually legitimately stress them out with noise. So D is the best answer. They actually did that with I think like pigeons or something. That's the thing. I'm so serious. They stressed them out with noises, and then they left. Which biome has year-round rain and warm temperatures? Blah blah. Which one? Ooh, I see A and I see B. Which one is it? I think it's the tropical rainforest. So, yes. Alright, which biome is dominated by a few evergreen trees, got a couple moose hanging out, long cold winters, wolves, bear, and lynx? Alright. Tiger. Alright, good for you. Yay! Do this one. Alright, what you got? It should be, come on. Give me your best shot. Carrie, what are you doing?
I'm trying to see it.
Oh, okay. So it is resource partitioning. So yes, this is the crazy birds with their names. All right, here is a climatograph for Russia. The tundra winters are. Okay, great. I think I left it out because I was like, that's a really easy question. All right, so let me switch to PowerPoints. Take 1 minute to stretch and not listen to me talk.
Realize something that would be fun disclaimer. There's really no point because we're about to take the test, but in the future, do you know the game where you have the thing above your head and you have to guess what
I've done that with vocab before.
Have you?
Yes. I just with this class it's hard because so rushed.
Jada, I think that's your highlight.
Especially now that we're on block, it's very rushed. Yellow-bellied sapsucker. Don't forget that part.
Yeah, I should take a picture of that and save it.
I'm going to put that on Twitter. Do you follow me on Twitter, Elaine?
Yeah.
You do? Aww. So
I
happy
don't
now.
follow very many people. I just got it, so.
I find that as a compliment. I really use it more. This is the nerdiest thing I'm going to ever say. I really use Twitter to learn.
Yeah.
I use other things for social interactions. Okay.
It's not that terribly social.
That's okay. I mean, it's neat. I get to talk to people in other places. Those are not rocks. Hey there. All right. So the oysters. Oh, did everybody see the pictures of the rocks though? These are oysters in Chesapeake Bay. The oysters in Chesapeake Bay are actually really good at filtering out water. And so what they do though, unfortunately, they are kind of gone. Chesapeake Bay was the world's largest oyster fishery, but by 2010, reduced to 1%. We overharvest them. Look, see, overharvesting and habitat destruction. So there's part of my Hippo C. Disease was also part of it, not in our little acronym, but important. And what ended up happening was the areas around Chesapeake Bay, let me show you this, the areas around Chesapeake Bay, there were some farming communities, and so what ended up happening was fertilizer gets into the water and it makes algae bloom, which sounds good, like, oh, algae, they make oxygen. But when they die, bacteria come along and they decompose them. And so what ended up happening was you had a problem with hypoxia. This is something I'm going to teach you at least 12 times before May 2nd. So here's the first time. Hypoxia, hypo means low, right? Like hypoglycemics when your blood sugar's low, hypoallergenics where like your makeup doesn't make your face go crazy because it has low allergens. So hypo means low. So low oxygen. So if oysters need oxygen, right, because they are alive, no child left behind, oysters are alive and need oxygen, so that was a problem. A lot of this, I'm skipping. I'm going to have to talk about this actually. Alright, so positive and negative feedback loops. This is also something I'm going to be talking about a lot. But positive feedback loops, they sound like really good. Like, oh, that sounds like positive. Like, this is good for the earth and everybody. Positive in this sense doesn't mean good. It means it grows. So let me give you an example. I don't know if y'all knew this, but I used to be hot heavy. And so I like cookies, and that's fine. But, like, do you ever get, like, I'm allergic to cookies, but there was a day where I didn't know I was allergic to cookies yet, and I'd be like, these are some good Girl Scout cookies. Those ones with the coconut on them with the
Oh,
fudge stripes.
nice.
Yeah. That's what's up. So you eat one cookie and you're like, that's a pretty good cookie. And then you eat a couple more. And then you're like, I feel sad that I ate that many cookies, right? So then you eat another cookie because you feel sad. Then you
Might
feel
as well.
worse, so then you eat some more cookies. Then you feel really sad, so then you eat some more cookies. Then you feel sad, so you eat some more cookies. And really, like, you just keep eating cookies, and that never gets better. Do you see what I'm saying? So that's a positive feedback loop. On Earth, that would be like saying, for example, if we have, with climate change, for example, if you have ice on the surface, like at the North Pole, well, ice is white and it reflects light, right? That's good. But guess what happens when it gets hotter? Ice melts. It exposes dark-colored water and dark-colored ground. So guess what? That's going to absorb heat, and then more ice is going to melt. And that's going to absorb more dark-colored surfaces in water, and that's going to absorb heat, and it's going to make more ice melt. And then it's going to expose more dark surfaces and like dark-colored water, and then it's going to absorb heat, and then more ice is going to melt. Do you see how I keep saying that over and over and over and over and over again? It never ends. That's a positive feedback loop. So positive feedback loop says it means good, yay. It actually sounds like everybody's going to die, okay? And it just keeps growing. So a negative feedback loop is I eat one cookie and it was good, and so now I'm happy. Or in the climate, for example, positive feedback loop, negative feedback loop would be like it gets warmer, so more water evaporates and makes a cloud, and clouds cool the earth. It's one sentence. Negative feedback loops are one sentence, and it has like a happy ending. Yeah? So, anyway, that's the difference. I didn't even know what this says. I don't care. That's the answer. What?
On the next
Yeah, so it stabilizes the system, whatever. So, you should be able to look at a situation and tell if it's going to keep growing and sort of getting worse, I guess you could say. That's positive feedback loop. Negative feedback loop is just kind of one thing. So a negative feedback loop is you get hot, so you sweat, and then you're feeling all right. One sentence done. Doesn't grow. Okay? That's a negative feedback loop. Most things in nature are negative feedback loops. Don't have that. So positive feedback loop, I was talking about this with the sea ice melting. Also, cancer continues growing. There's something that really stops it. So this is a little more rare. So this is what I was trying to tell you about. I'll turn the light off. So, like I said, you have this ice. It covers the surface. It's white. It reflects light. Some melts. So climate's still warm though. So this water is going to absorb it, make it hotter, and then this continues until all the ice melts. Isn't that happy? Good times. We don't need to talk about that. Nope. 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 This is the thing. Okay, so here we go. Are you listening? So you have farms, and farms use the nutrients. These are the two big nutrients that are really needed. These are called macronutrients. Phosphorus and nitrogen are macronutrients. So macronutrients. That means you need a lot of them. Have you ever seen nitrogen on like a nutrition label? You ever seen phosphorus on a nutrition label? Carbon on a nutrition label? That ringing some bells? Carbon? No, because it's in everything, right? Phosphorus, nitrogen, carbon, those are macronutrients. You need a ton of them. They're in everything, okay? As far as food and energy goes. So farmers use nitrogen and phosphorus on the crops. Now, if crops and plants on land need phosphorus and nitrogen, guess what else needs it? Aquatic plants, like algae. So what ends up happening is you have these little algae, and they're gonna just do great. They're gonna be killing it. They're gonna do awesome. But then they're gonna die. When they die, they become snacks, or things like bacteria, the detritivores. Do you remember them? Now, bacteria are alive. Bacteria need oxygen. When bacteria eat the dead algae for dinner, they use oxygen. They use all the oxygen. And so what ends up happening is this dead area where the bacteria is consuming this waste, it becomes hypoxic. So you have this hypoxia problem. Hypoxia. hypoxia is the end result. That means you don't have enough oxygen. And then the fertilizer, all that, when you have too many nutrients, that's called eutrophication. Too many nutrients. Eutrophication means too many nutrients. Hypoxia means after the algae bloom and bacteria use the oxygen. Because like when you eat dinner, you need to breathe and eat. So if I put a pillow over your face and you have food, that's not helping. Okay? I'm just saying. So bacteria, when they eat the dead phytoplankton or algae, they use oxygen too. And so then you end up getting low oxygen. This is why the oysters in Chesapeake Bay, that's why they died. Because the hypoxic conditions after the algae died, which was from the nutrients that made the algae bloom. Are you kind of following me there? You okay? Eutrophication is too many nutrients. Hypoxia is a different word. It means after the stuff is bloomed and then dies and the oxygen gets used. I'm going to explain this at least 12 more times this semester. That was the first time. So anyway, if you see here, here's Chesapeake Bay. This is the watershed for Chesapeake Bay. What a watershed is, this whole green thing, a watershed is the area of land that sheds water into a river or a lake. So all of this green thing, this is all the land that drains into the Chesapeake Bay. So that's the Chesapeake Bay's watershed. We're part of the Coosa River, and well, I guess we're Etowah more closely, but we're part of the Etowah River watershed. That means if you go outside and turn the water hose on, it's eventually going to go down to the Etowah. That's just, it's the land that sheds water into a body of water. So, anyway, if you look here, here's your dissolved oxygen. 0 is red. So, yeah, no wonder the oysters died, right? But this is right around D.C. and Baltimore. Parts of Virginia. So this is a really big bay, and there's no more oysters now. Is that kind of depressing, right? Kind of sad talking about it. So anyway, the lithosphere, atmosphere, biosphere. The lithosphere is the rocks, atmosphere is the air, hydrosphere is water, biosphere is the living stuff. The one that people don't know is lithosphere. The lithosphere ended up being the sink for most of those cycles. I don't know if you noticed that. Should have heard that word before. Ecosystem, living and non-living things. This is a big idea. The AP exam will try to trick you with this. Energy goes in one direction. So, and this is, we talked about the laws of thermodynamics. The second law of thermodynamics says energy goes from awesome to crappy. Yeah, so energy goes in one direction. You can't reuse energy. You can't put a bubble around yourself after you eat a Big Mac and use that energy again. That sounds dumb because you can't do it. So anyway, matter though, we can recycle matter. So this is where you have to learn your carbon cycle, phosphorus cycle, all that comes in. You can, the same water that you're using today, some dinosaur had, right? We don't get new matter, but we just reuse it. So let me give you another diagram of that. If you look here, you can see energy from the sun goes through the food chain, woo, and then gets decomposed. Two different pictures. Energy from the food chain energy from the sun goes through the food chain and gets decomposed. So it goes one way. There's no, there's not a cycle for this. And y'all know that if the sun goes out, we're all going to die, right? You know that's a thing. But the reason that's a thing is because that has to come in and be an input every single day because it's the second law of thermodynamics. It's deep, right? But talking about matter, matter is cycled back through these decomposers and detritivores. They're the ones that do that. They take the dead stuff and break it down, return it to the soil, and then it gets reused. So matter can get recycled. Energy goes one way. Primary production is another word for photosynthesis. This slide is super important. It's so important, I'm going to go to the white screen and talk about it. Have we talked about gross and net primary production? Did we kind of do that? Maybe. Maybe we did with the little seeds, but I'll talk about it again. Alright, so plants make glucose, right? H12O6. There. Y'all, that's photosynthesis. That's primary production. Primary production. Am I blowing your mind by putting pee-pee around there? Anybody chuckling? I have little kids, so I think it's funny. Anyway, plants use some, right? They don't use it all. Plants use some glucose. And then you have some left for everybody else. So this is your glucose left. And so who is this glucose left for? These are producers. Who's it left for? Everybody. Yeah, so glucose remaining for consumers. So, do you know how you have a job and then you make money, but then you don't bring it all home because the government takes it? And do you know the gross and net pay? Does anybody have a job or your parents have a job? Okay, so you know that they don't bring home everything, right? So this is your gross primary production. This is everything that gets made. Primary production. This is what's used for respiration of the plants, minus respiration. You want to guess what this over here on the right-hand side is? It's the net primary production. See that?
And so this goes back to the whole energy biomass or whatever you call period where.
Right. So you loosen that, right? And then not everything gets eaten, and some things, energies used for moving around and growth. But yes. So this is net primary production. So this is GPP, is what this is called. Gross primary production. This is net primary production. So in the AP exam, what they'll have you do is they'll tell you the gross primary production in an ecosystem is whatever, 20,000 kilocalories. And then plants use so much for respiration. How much left is available for consumers? So they'll word it like this. They surely won't give you this formula, and they won't tell you what those words mean. But it's really simple, but you have to just think your way through it. Are y'all okay with this? It's easy, right? But then when I go back to that other screen, they don't say that. They don't say it like that. So gross primary production is that total amount. You should highlight all this. Net primary is the energy remaining after respiration. So this is what is used, or excuse me, is available to heterotrophs. Heterotrophs is another word for consumer. So that equals consumer, right? It's not enough that you have to learn it, but you have to learn 4 words that mean the same thing. It's fun. I enjoy this. Secondary production is the biomass made by consumers, and productivity is just this rate that ecosystems are making biomass. And the productivity is going to be the highest, like we talked about a second ago with the tropical rainforest, is going to be the highest at the equator because you have that sunlight, which is the energy behind all of this. So photosynthesis is driven by the sun, so you're gonna have that to be highest at the equator. So anyway, high net primary productivity. This picture's on your test, and so the general gist is, if you look, this green is terrestrial, which means land, terrestrial biomes, and these are ocean biomes. And so most of this over here is near the poles. So I'm talking about like desert, also low sunlight or low moisture. Notice we have like boreal forest and the middle of the tundra. But if they go over here, the highest primary productivity or biomass generation, tropical rainforest and then coral reefs. So tropical seasonal forests, estuaries. But as you go toward the equator is the trend. Yes, sir.
Oh, I'm just stretching.
Okay. Next, so here you can see the equator. This is net primary productivity. It increases with temperature and precipitation. Feel free to highlight that if you didn't understand it or need to look back at it later. So there you go. So as you have more nutrients, more sunlight, and more water. So anyway, macronutrients, you need a lot of them. And I accidentally kind of spoiled my thunder a minute ago. I actually named like these 3. I need to stop. I guess maybe I should stop like reading the notes beforehand. I don't know. Micronutrients. Y'all are getting, like, I've probably done these PowerPoints at this point like 50, 60 times now. So I kind of know them, you know. Micronutrients, these are smaller amounts. So things like, this is if you eat a Flintstones vitamin, that's a micronutrient. So you like iron, manganese, what is that even, right? Stuff like that. So in smaller amounts. Even something like sodium could be an example. Oh, here you can see this kind of different color in this little bay. You can see that water is kind of cloudy and gross looking. That's what eutrophication looks like when you have too many nutrients. It kind of gets that discolored color from the algae.
What's the vitamin between this? Is that something man-made or?
A lot of times water won't mix when it's a different temperature, but I don't really know. So anyway, hypoxic zones. Most of them are due to farms and agricultural runoff. Some of them are seasonal based on those monsoons, but it costs a lot of money as far as lost fishing harvests when you have those problems with hypoxia. What's the problem? Oh, okay, so all these black dots represent dead zones. That's everywhere that people live. The Gulf of Mexico is an awful, terrible dead zone. I mean, there's just areas where you have no dissolved oxygen. Like, none. Because, you know, what feeds into the Gulf of Mexico is this, the whole Midwest where we grow our food. And so that drains off into the Mississippi and then into the Gulf. So these are just basically, these little dots represent, like, places where people live and where oceans drain into the water. So isn't that fun? Good times. Ecotones and all this, let me just kind of, this is where I need to be. I'm going to explain all those words. I'm going to talk about, feel free to go ahead and highlight ecotones and landscape ecology and patches and mosaic. So all of these words here, go ahead and highlight those. I don't want to say anything yet. I want to show you in the picture. I think that's going to make more sense. But ecotone, landscape ecology, patches, and mosaic. So let me kind of talk you through this, okay? Okay, so let's start with ecotone. An ecotone is, see this red line? Over here we have sort of a nice forest. So this green is a forest, and this kind of tan color is a grassland. This red line between them, if I zoom in over here, is an ecotone. An ecotone is that boundary between two different ecosystems. So ecotone is just that boundary. So no worries there, right? If I look closer at that ecotone, you can see little patches of each ecosystem, and those are called patches. Let's see, what else we got to talk about? I guess that was the biggest one. All this together, that's where that mosaic word comes together, and the people that study this are called landscape, or what was it? Something ecologists. Is it landscape ecology? That sounded dumb when I said it out loud, but okay, good. Did that cover all the words that I was going for? Corridor. Did I tell you to highlight corridor? Okay, it's coming then. Corridor's coming. If you'll look real quick with me, I'm going to show you what that looks like. See how I have a forest right here? And I have forest over here? There's a little strip of land that connects it. That's called a corridor. It's kind of like a corridor is a fancy way of saying hallway. Like if you're doing the SAT, a corridor is a hallway, okay? Or a pathway that like connects things. So this corridor right here, if like I was a deer and I wanted some water out of this nice little river or lake, I wanted to like hang out. I don't know what deers do. But this corridor would allow me to get over here in a sheltered, similar community as far as the vegetation goes. And so a corridor is really important when we talk about travel paths. So that border is the ecotone, the patches, I showed you that, and all the patches together is called a mosaic. So conservation biologists study this. That's not that important. Nope, 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 nope. Not really. Alright, so here we go with the, here we go. You might want to write down corridor if it's not on here somewhere. It's just that it's sort of a connecting area of undevelopment that can kind of get you from one patch to another. I guess that would be the best way to say it. It's really important. Corridor. Corridor. If feel like I just did a spelling bee. Corridor. C-O-R-I-D-O-R. Corridor. Can you use that in a sentence? What is this language of origin? No. No? Is that not funny? I think it's hilarious. So anyway, so this is another one of those things where it could have 7 different words that mean the same thing. When we start, I'm about to tell you about the nutrient cycles. I know you're excited, right? So a pool is where stuff stays. It's another word for that is a sink. I mean, that sounds like, why is there so many words for this? But a pool and a sink, that's where stuff sits for a while. Like, they're both basins. So a pool and a sink, and you can kind of see the similarity. Flux means it's moving around. So moving. So when we're talking about nutrients, stuff either moving, that means it's in flux, or it's being stored for a while. It means it's in a sink. So those are those words. All right. So again, source and sink. Yeah. Okay. Thanks. Doesn't matter. So water cycle. Not really going to talk about water cycle that much. I will tell you one thing. Sometimes on the AP exam, you guys know that plants release water, and you know that evaporation is water, well, evaporating, but going into a gas phase. Sometimes the AP exam people will put these together and they'll call it evapo. I'm gonna try again. Don't judgment free. Okay, they'll call it evapotranspiration. Evapotranspiration. And so they'll just put those 2 words together. So evapotranspiration would be all the plant water that's getting evaporated plus the water that's evaporating from like lakes and stuff. So that's the only thing that's weird there that you might see. Moving on. The water cycle. Aquifers are like water's house underground. And so an aquifer, people don't know the difference between an aquifer and like a water table. People don't know what that means. We'll get into this when we study water a little bit more. But aquifers is like, they're these spongy layers of rock where water could be. Or water could be found underground. So, there's a sponge-like. So, if I'm looking at an aquifer, and we'll go into this and we'll get into Unit 5 a little bit more. If this is a layer of rock under the ground, like these little circles that I'm drawing, those are pores in the rock, and these places could be filled up with water. People are so funny. There, I'm going to give it some water in the aquifer. People are so funny. You have a well, and they don't understand that the rock that they're pulling that water from is not like in this beautiful, like open, like area underground where there's nothing but water. That water is in between in rock and like little holes, and then when you pump it, it sucks it out of the holes. But it can also be in cracks in the rock, but it's not like there's like a magical pipe where God just put all the water and then you drill into it. It's actually in little holes in rock. So, yeah. Anyway. You get to talking to people and you're just like, oh, maybe we should discuss that. The water table is that, I shouldn't have erased all that. And let there be water. So, let's say that up here, there's my aquifer, that's where the water lives. Let's say up here that there's no water. Magic, magic, da-da-da-da, and also no lines. Could have probably drawn the whole thing again. See, down here I have water and up here I don't. In an aquifer, that upper limit of water is called the water table. So, if it rains and this gets filled up with water, then the water table goes up. If it's a drought, the water table can go down. You should highlight that. There. I highlighted it for you. Looks good. Alright, I can get through all this. There's the water cycle, good times. The biggest impact we have on the water cycle is irrigation. And so irrigation, and we have dammed rivers. Eternally, we've dammed them. And so anyway, that's the biggest things we've yeah, so, and I can make so many more jokes, but I won't. But the biggest thing is irrigation. Most of our fresh water goes into either irrigation or industry. So anyway, carbon cycle. The biggest thing with the carbon cycle is this is where our little plants come together. You have photosynthesis, right? They're going to remove carbon dioxide and make oxygen and glucose. Plants are a major reservoir, but the biggest test or quiz, the biggest sink is the lithosphere. And so, like sedimentary rock in the lithosphere is the biggest sink. Anyway, so this is where we're really talking about plants and respiration and all that. And then as far as how humans have, okay, oops, I'll ruin my fun. There you go. There's the sedimentary rock part. Ocean also holds a lot of it. I won't get into that too much yet. We'll get into that later. But here is the carbon cycle. As far as humans and their impact, this is what we're doing. We're taking fossil fuels that have carbon in them, like oil and coal, whatever. Those things are rich in carbon, and they've been sequestered. Have you heard this word before? It means to store. So carbon has been sequestered underground in fossil fuels for about 400 million years. And so it's been chilling out, stored underground in oil and coal and natural gas. And so what we're doing is we're taking it, it's been sequestered, it's been in a sink, it's been in this lithosphere, and we're releasing it as CO2 in the atmosphere. So it's gone from being sequestered, and now it's in flux. So it's moving around the atmosphere as CO2. And so that's the biggest impact that we have. And when we talk about this, we're talking about climate. Climate change causes climate change. And this is because it's a greenhouse gas. That means because greenhouse gas. Alright, so that's the issue. So we'll have a whole unit on that. But when we talk about climate change, when we talk about global warming, we're really talking about carbon that's been sequestered, but now it's in flux in the atmosphere. And so humans are, doing this. And that's the issue. Two biggest things, this was on your quiz. Exactly on your quiz. What are the two biggest things that humans have done to modify the carbon cycle? Burning fossil fuels and cutting down forests. And you guys said that. You did a really good job on your quiz with this. So good job. And that's the driving force for climate change. Do y'all have a question? No? Okay, so anyway, that's really important. Nitrogen cycle stinks. Like, it's so confusing, right? I gotcha. So I think I might just, magical things happen when I just say whatever and just go to this board. So y'all know that most of the atmosphere is nitrogen. The sink for nitrogen is the atmosphere. Do you know what it looks like in the atmosphere? Yeah, it's N2. So if you wanted to be a plant, this is the thing. Plants take up nitrogen, right? If you want to be a plant and you wanted to grow from nitrogen, you breathe in and out nitrogen every day. Is it like reacting with you and doing stuff? No, it's inert. It doesn't react. Inert means does not. That's, I think, the 10th SAT word I've just told you today. So this nitrogen gas is inert. Feel free to write this down or not. It doesn't react. Okay? So as far as we're concerned, if we're a plant and we want to grow, guess what? It's broken. Don't put on the AP exam that the nitrogen in the atmosphere is broken. But the reason I'm telling you that is because the first step in the carbon cycle is nitrogen. Would you like to give me the second word? See where I was going with that. Isn't that nice? So the first step is nitrogen fixation. And that takes the nitrogen and it converts it to ammonia. And you could go ammonia or you could go ammonium. It's not the same, but for this class it doesn't matter. Whatever. It converts it to ammonia. We'll go ammonia, okay? So there's ammonium. It converts it to ammonia. Does ammonia sound like nitrogen? No, that doesn't even sound, that doesn't sound like nitrogen. So the next one takes ammonia and it turns it into a word that sounds like nitrogen. it turns it into nitrates. And so the next step is nitrification. It takes ammonia and it makes it sound like nitrogen by being nitrates. So the next step is nitrification. I don't think that's the right vowel there. I fixed it. It looks good. I got it. Nitrification.
So that's I guess a big factor of why ammonium nitrate is such a common fertilizer.
Yes. Whatever. Nitrification. Edit. I don't even know. I think it's just this. There. All better. That's a lot of I's to write by hand. And so it takes ammonia, like I said, and it turns it into something that sounds like nitrogen, which is nitrate. And it could really be nitrite and then nitrate. Like I'm simplifying. So, and then the next one is really easy. Like you just have assimilation. And that just means it gets sucked up into the plant, whatever. Assimilation. Okay, so those are the things. The rest is easy. So I'm going to go back to the picture now and talk about it. This is like where these two people are, I don't know, but you have to keep them straight. So that's I made up of like a little story to help you out. It's broken, you got to fix it. Then crap, it don't sound like nitrogen. So nitrification makes it sound like nitrogen, makes nitrate. I'm a simpleton. What are you looking for? So anyway, the nitrogen cycle. Oh, you guys, some of y'all screwed this up on your little quiz. That's the issue. It's in proteins, DNA, and RNA. Okay. So, hey, Jada, this is the nitrogens and the hydrogen bonds, right? This is the nitrogen. Okay. Anyway, so fixation. Oh, how does it get fixed? Two different ways. It could be through lightning. So if you're taking the AP exam, just be like, nitrogen fixes that. That's fine. Or bacteria can actually fix it. And if so, it makes ammonium or ammonia. You can say ammonia. Ammonia's fine. Ammonium has one more hydrogen. So. And plants are cool. They can work with ammonia. They can't really do a whole lot with the nitrogen in the air. So here's root nodules. So root nodules of legumes. I know I'm not going to get done today. Your test won't be the next day we come back. So, I know I'm not going to get done. This is important. I can't rush through it. So, don't freak out. You're making that face like, you're not going to finish in 9 minutes. Don't think it's 5 minutes. So, anyway, legumes are like soy or peanuts. Also, things like alfalfa. And so these root nodules of legumes can actually do nitrogen fixation, which is really cool because nitrogen fixation is the problem. We have tons of nitrogen in the atmosphere, can't do crap with it. So anyway, when you go and buy Doritos, like they're perfect because the farmer in Iowa can grow corn and that sucks up all the nitrogen out of the soil. But then he can grow soy, he can rotate and do crop rotation and grow soy, and the soy will put the nitrogen back in the soil. And then they can make Doritos out of corn and soy. When you go to the store and you buy something out of the bag, it has corn and soy in it. And even if you buy vegetable oil, soy is not a vegetable. It's like a little legume. It's in a pod. It's not a vegetable. But if you look at vegetable oil, it's actually soybean oil. And all of our oil is made from this because the farmers are using it to replenish the soil with nitrogen. They're helping it to do nitrogen fixation when they're making ammonia. So, the root nodules can do this. Pretty cool, right? Only legumes are the ones that you need to be familiar with are legumes. So nitrification, like I said, is going to convert it into nitrite. Then nitrate's fine. Plants can use the nitrate. That's not a problem. That problem with the nitrogen cycle is that first step, that nitrogen fixation. So nitrification, I already told you this, makes that nitrate for you. No problems. And after stuff dies, denitrifying bacteria, denitrification puts it back into the atmosphere. That's not really that confusing. That's the easy part, right? This is not an issue, right? Denitrification puts it back into the atmosphere. Fine. And now I have a picture. So, as far as what humans have done here, here's the fixation due to lightning. You got 4 there, right? Yeah. Humans, when humans burn fossil fuels, they do actually put a little nitrogen oxides into the atmosphere, that NOx that was on your summer quiz. But the biggest sink, like I said, by far is the atmosphere. So, all right. So these chemists actually, pretty interesting. They figured out how to do this artificially without needing bacteria and the root nodules of legumes or lightning. And so what they did was they figured out how to take nitrogen gas and hydrogen gas and make ammonia. And so if you go and you fertilize crops like your corn, they don't spray nitrate on that. They spray ammonia. And so if you buy fertilizer that has nitrogen, you're going to buy ammonia. And it was made through the Haber-Bosch process. Thank you, Judge Chemists. We appreciate it. Negative side effects. This is where we go back to the Chesapeake Bay with the eutrophication. So the negative effects of this is it's going to cause eutrophication, and then it's going to cause hypoxia later. Like I said, the nitrogen can also go into the air. This is not going to be in your chest. This is a whole other unit. So just right now, get the eutrophication in your head. Can only learn so much. Oh, I don't know what that is. Next. So the phosphorus cycle. The biggeth thing about the phosphorus cycle, here, let me tell you about it. The sink is the lithosphere, and every year on the AP exam, they will ask you about it, and you have to know it has no atmospheric component. There it is. They will ask you that. So the phosphorus cycle is like phosphorus is in rocks. Phosphorus gets weathered out of rocks. Phosphorus goes into a plant. A plant dies and makes a new rock, and then it gets weathered out of rocks. That's all it is. It's like the easy cycle. Real seriously. That's all. It's in rocks. It gets weathered out of rocks. Plants suck it up out of the rocks. Plants die, make rocks. Comes out of the rocks again. That's all. No atmospheric component. Major sink is the lithosphere. So look, there's like one part in the atmosphere, and then most of it, 4 bajillion jillion in the lithosphere there. See, that's just 4 billion. I'm kidding. So the biggest thing that humans do to affect it, again, with the nitrates, we're causing problems with eutrophication because we use it as fertilizer. Also, it's in poop, and then it used to be in detergents. So I don't know if you knew that, but have you ever heard the word phosphorus? It means to glow, right? Guess what they put in detergents to make your clothes kind of, like, they make your whites whiter than white. Like, honestly, God, they used to put phosphorus in detergent on purpose to make your whites, like, glow. And so, quit doing that after we figured out it caused eutrophication. Kind of like, you know, those microbeads they put in your face wash, how they banned those after they figured out that they, you know, fish were eating like a million of them. So, yeah, we want to be pretty and have our clothes glow in the dark, you know. But I don't know that they glow. They didn't glow in the dark. I'm kidding, but definitely was pretty nice. So anyway, fertilizer. Oh, we did it. All right, let's answer these questions. Which of the following describes a negative feedback loop? Negative feedback loop. Do the things. Alright, let's see it. B! Yay! It stabilizes. Good. Which of the following statements is not correct? Alright, not correct. So, let's see what you got. Let's see what you got.
It is correct.
Which is
Not. Oh, did I hit this?
Yeah, that one.
Oh, I'm sorry.
Oh.
So are we answering this one? Okay, so energy flows through in one direction, matter cycle. So that is C. Sorry. Let me know if you don't have that one. I edited it before I printed it for y'all, like I said, and so, which is the definition of secondary production? Secondary production versus primary production, right? See what you got? Alright, A is right. Good. Biomass generated by heterotrophs. So, Which biogeochemical cycle could have abbreviated that? Uses photosynthesis and respiration. You got this. You don't? Okay, it's carbon. Which you do?
I don't have it.
How do y'all, some of y'all have it and some of y'all don't?
It's that one. It's just
Where? Do it to it. Biogeochemical cycle is affected through fertilizer production through the Haber-Bosch process. This is important. Okay, looking like B, and that's correct. Nitrogen. It makes ammonia from hydrogen and nitrogen gas. Which of the following is not a way to decrease hypoxia in estuaries? This is actually a really common question on the AP exam, and it's so dumb and easy, but, you know. Not a good way to... Please get off the chair like that. Thank you. Oh, that's fine. You can stand up. Just don't stand up on the chair. Alright, so, yes, it is B, so you don't want to put fertilizer. And that should be all you have? Yes? Yay! Alright, so when we come back, it won't take the whole class period, but we'll do the other PowerPoint, and that's okay.